Okay. Starts. Can you hear me? Okay. Okay, good. Let me do a final check. Okay, good. So let me start. So this talk is actually extended version that I gave about a month ago in the IFC PY data talk. So the topic is about Julia, and the title is Introduction to Julia by Quant, Decentralized Programming for True Decentralized Systems. So what is Julia? Julia is a high-level, general-purpose, high-performance, cross-platform dynamic programming language. So what I mean by high-level is that in programming language, usually we have high-level and lower-level. High-level means that a normal programmer can actually code. And for lower level programming language that is like assembly or even C++ is considered quite low, and usually it looks more like assembly language, which is the machine language. But for higher level language, people like it because it's very easy to use, and just like Python or MATLAB. And also Julia is general purpose, meaning that it's not for a specific domain, unlike there are certain domain-specific language which is very suitable for that domain, but for other purposes, the language is not suitable. But for Julia, it's general purpose. Okay, and it's very high performance, and it has been used in project that reaches petaflop performance, and if you look at the benchmark, is as fast as C or C++. And it's cross-platform, meaning once you write the Julia programming, use the programming language, you can actually use it on Windows, on Linux, on Mac. So it's cross-platform. And it's dynamic, meaning that unlike, let's say, C or C++, which is static, meaning once you write the program, you need to compile it. So there's a compiler that you need to use for static programming language, so that it will translate into a machine executable binary code, and then you run it. So that's static. But for Julia, it is dynamic, meaning that you can just type and then it will give you a response. In fact, there is a repo, which is command line tool that you can use to get your results immediately, which is very good for, let's say, for data scientists, for quantitative trading, especially for those who want to see the results, the graph, to plot some graph. So all this kind of requirement has to use a dynamic programming language. So Julia is very suitable in this case. And also Julia is open source. It's completely open source. It's free under the MIT license. Here are the four co-founders, the co-creators of Julia. They started in 2012. So from left to right is Stefan Kapinski, Vishal Shah, Jeff Peterson, and Professor Alan Edelman. So the tallest guy in the picture is actually the CTO, Jeff Peterson. He obtained his PhD at MIT, and his supervisor at MIT is actually Professor Alan Edelman, which is the rightmost guy. Very fortunately, I was a student of Professor Alan Edelman as well when I was in my master degree courses. I took his applied parallel computing course, and I won a small prize as the best student of the class. So that's my relationship with the Julia team. Julia is currently in its 1.9 version, and it's very stable and well developed. It started, like I said, in 2012, and then the first stable 1.0 version was released in 2018. And since then, the industry, the community has recognized Julia as a very powerful, very suitable programming language for example, for data science, and also, in fact, in quant computing as well. A lot of quant hedge funds, actually I know a few actually are using it in their research and in their live trading. And both IEEE and CN has awarded the Julia team with a prestigious award as well. And Julia also has the next generation. In fact, over the world, there are at least 1,700 universities are currently teaching Julia in part of their course. So in some sense, even though you may not see Julia program, Julia project in the industry at this moment, but I mean, in the long run, when the next generation come up, they will know Julia much better than the current industry. Okay, I think Julia is very, very special as compared to all the programming languages you have seen in the world today. At least it has 4 features that I want to focus on in my talk today. First of all, it's called multiple dispatch, and it has 100% user control. What I mean by that is that if you look at today's software, most of the software are actually controlled by big companies. For example, let's say the Windows, the Mac operating system. Well, sometimes you want to change some features, like say you don't like the way how the operating system works. In some sense, you want to change it, but you can't, because all these source codes belongs to Apple and Microsoft. So you have no chance to make any change unless Microsoft or Apple decides to do it. Okay. And then you may say, well, what about those so-called open source projects? Okay, of course, there are a lot of open source projects, and if you look at those projects on GitHub, there are thousands of people actually using it, but unfortunately, they are not 100% user control. Let me give you an example why I say those open source projects actually not 100% user control. Back in November 2021, there was actually a very big accident, a very big event in the software industry. And one of the most widely used software, which is called Log4j, it belongs to Apache, was identified with a very serious bug. Let me show you the okay, I'm sure you can see it from the screen now. So this bug was actually found out by some Chinese developer in one of the largest cloud computing company called Alibaba Cloud in China. The bug looks very small, you know, it's just a few lines of code in the Log4j package. It's open source, but the vulnerability actually is very severe. It belongs to a highest level of in terms of the severity, it's the highest level. And what it does is actually allows remote code execution. That means anyone who knows how to exploit this this bug can actually install software in all those machines, all those servers, and also even like the Android phone that you are using, probably some of the operating system package is actually using Log4j. So it's very, very serious. Unfortunately, it took them at least 2 weeks to come up with a first patch. This is considered, 2 weeks, this is considered very, very long, because any bug of this kind of severity has to be dealt with, let's say, in minutes or in hours. Otherwise, the whole server could be down. All the data, all the very valuable and very private client information will be leaked because of this bug, because it allows remote code execution. And you may ask, why can't those big companies come up with like a fix just to fix it? Unfortunately, this is how the world's software works. Even though it is open source, it's like a giant machine of all kinds of components inside. And even if you can identify the exact component, like let's say like a big machine, there's one of the let's say one of the two inside, you want to change it, you can't, because all of this software is complicated. It's very complicated, and in order to make any small changes, you have to do a lot of work. And this kind of work, and of course you have to make sure that whatever you change cannot affect the rest of the software. So in this case, if you want to change anything, it's much more difficult than you think, because although it looks like it's open source, it doesn't mean it's free of bugs. It doesn't mean it's very easy to debug. It doesn't mean it's very easy to fix any bug. So that means whatever you run in your computer, in your server, in your company, you don't really have 100% control, because the way how the software, the infrastructure is developed, which is very sad. But this is going to change because of Julia. Because Julia has this feature called multiple dispatch, that it allows user to write code to overwrite existing codes, which I will explain later on. And also Julia is very special in terms of its accuracy. Most of the software, or most of the library or packages you find today, software, purely software, that it's almost like a layer of computer science. Okay, so and then you build another layer on top of this computer science layer, which is maybe a mathematics layer, and which contains a lot of the mathematical library that you want to use. But this is not what Julia, the Julia was built, because when Julia was designed, I believe they took into consideration of mathematics together with computer science. That's why a lot of this feature, for example, like accuracy, all this feature, they built inside. So if you want to run any complicated, let's say, mathematical model, let's say in quantitative finance, you don't need to, at least you have a peace of mind, because Julia takes care of a lot of these things that it will be exposed to you. Unlike Python, for example, a lot of these features in Python, although it looks like it's very easy for you to use, in fact, it hides all these kind of potential problems, potential inaccuracies. So you have to be extremely careful. But for Julia, you have a peace of mind. So this kind of feature is very, very important. Also, in terms of the performance, like I said, Julia has a performance like C or C++, and also it's very easy to use. It has a language feature that's very similar to MATLAB and Python. So it combines the ease of use of Python or MATLAB with the performance of C or C++. So if you combine all these 4 features together, I believe this makes Julia the world's first decentralized programming language. Okay, let me explain a little bit more about multiple dispatch. So in computer science, one of the prominent or the whole industry is actually using is called object-oriented programming. So it's a paradigm of how you design any software. Okay, essentially what OOP, object-oriented programming, OOP means is that you abstract the real life an object with a class. In computer science, we call it a class. And the class consists of attributes and methods. So attributes is basically all those kind of properties, right? So you have color, you have the weight, and the number, the age. So all these are attributes, okay? And then inside the class, you also have methods. Methods is actually some procedures that you process those attributes. For example, you can write a function that a method which to calculate, let's say, what's the revenue of the last 6 months. Okay, so all of this are encapsulated inside a class, and that's what object-oriented programming is all about. However, this actually has limitations because you see sometimes some people, they have the attributes, okay, but they don't have the methods, okay? And there are some people who has the method, they can write the method, they can write some functions, but they don't know the attributes, okay? And sometimes some people developed a class, developed a software with attributes and the methods, but when you want to use their code, when you want to use their software, you want to change it, okay? You want to change the methods, or you want to change the attributes. How can you do it? It's very difficult with object-oriented programming because the attributes and methods are very closely coupled. But in Julia, it has multiple dispatch, which decouples the attributes and methods in OOP. And it actually uses something called struct and function. A struct is basically a way of designing your attributes. So it builds a struct. It can be mutable or immutable, okay? And you can design a function. You can write a function to work on those structs, basically, or primitive types. And both of these struct and the function can be written by anyone, anywhere, at any time, and it can run together. Okay, your struct by your friend's function and with your own modification can be run together in your machine, on your machine, at any time, without any changes. So that's what Julia can bring to the industry, and this actually allows decentralized ownership, and it gives complete or total transparency. In other words, if you find there's anything that has a bug, for example, in the log4j example that I mentioned, you want to change it. But in the current software industry, it's almost impossible. It's very, very difficult. I mean, for example, if you write some C++ code, and really big production level codes, you want to make some changes, even though you are a very smart, very experienced software developer, and you have all the rights to make changes, and you are super careful with whatever you write. Just to compile it, just to compile the whole package, it will take hours. I mean, this is the case in one of the quant hedge funds in London. I can guarantee you that such kind of changes is very, very difficult, and it's very time consuming, and it's very error prone. But with Julia, you can change it with one line of code without compiling the rest. And this gives you, like I said, total transparency, and you can do it in production straight away. Okay, let me give you an example, what I mean by multiple dispatch. In this case, we have all the structs. Here we have a tennis player style, and we can have Federer, Nadal, or Djokovic style. So all we have here, we have three structs, and then we can define a function which can be written by you, can be written by me, or anyone else to work on those structs. For example, let's say we have a compete function which takes a Federer and Nadal style, and then you can print like the result. Okay, so like I said before, with multiple dispatch, you can actually overwrite whatever other people have written. For example, if you don't like Nadal to beat Federer, you say that Federer beats Nadal. So every time Federer plays with Nadal, Federer wins. Okay, so you can change it on your machine, and then when you run it, when you execute it, it will print out Nadal beats Federer, and with the rest of the code unchanged, untouched, stay where it is. You don't have to change anything, just to write another function, which is the function that Federer beats Nadal, which prints out Federer style beats Nadal style. And that works. So that's what I talk about multiple dispatch. So it gives you 100% user control. Okay, with multiple dispatch, it is not enough. In fact, I believe in the near future, most of the programming languages will start to incorporate multiple dispatch feature into their new versions, following Julia, of course. But multiple dispatch alone is not enough. We need accuracy. Like I said earlier on, we have to incorporate mathematics together with computer science inside this programming language. Let me give you some example. In string concatenation, let's say you have two strings, hello and world. You want to concatenate together. How do you do it? In Python, the string concatenation actually uses a symbol, plus symbol. So what you will write is hello plus world, and then it will print out hello world. Okay, so but in Julia, it's actually using the star, like multiply. Okay, what's the philosophy behind? What's the logic behind? In fact, in mathematics, if you look at plus, a plus b equals b plus a. So you can actually swap the position. So it's mute. You can commute it. But a times b does not equal b times a. For example, if A is a matrix, matrix A times matrix B does not equal to matrix B times matrix A. So that's the difference. Okay? So in Julia, the designer actually incorporates mathematics inside. Also, in statistics, let's say if you want to calculate the standard deviation, which is a very, very common widely used package that you use in Python, the default setting is that the degree of freedom is actually, in Python, it's actually n. But in Julia, it's n-1, which is the correct, is what you actually need to use. It's actually n-1 as a degree of freedom. But in Python, the default is n. Of course, there are parameters that you need to specify like see the degree of freedom to be n-1. But in Julia, the default is right. Okay, and the third example, the one that I want to talk about, is approximate, because a lot of people have this impression that you have a mathematical formula, which is, let's say, very simple, a number, okay, 1.0. And you think, well, this is a very simple floating number, 1.0. There's no ambiguity. Yeah? But once you write it as a computer software, once you write it in a programming language, this is not 1.0 anymore. In fact, on your machine, it could become 1.000000001 or 0.999999999. Okay, because they are the computers that we have today have finite precision. Okay, and the error is actually very, very small. Let's say 10 to the minus 20. Okay, so this kind of very small error is not a big deal for let's say your daily use, but it's very serious if you want to consider quantum finance, if you want to build complex or complicated programs, because there's a lot of calculations that's involved, and this kind of error can be cascaded. And it has been shown by experts in numerical analysis that all these kind of small errors can cascade it into something very big, even to invalidate, for example, central limit theorem, which is the fundamental theorem in statistics, and is widely used in quantum finance. So you have to be very, very careful with this kind of calculation, these errors, numerical errors. So in Julia, in fact, they are very careful and they do it in a proper way. And in fact, today I will be able to show you some demo, because actually at the PY talk, I wasn't able to, because of the limitation of the time and the setting and so on. But today I'm going to show you some example. And also, besides this numerical error, Julia also has Unicode support. So if you want to write mathematical formulas or mathematical symbol, let's say pi, you can just write it just like that, you know. So it's unlike in Python or in other programming languages that you have to write pi as pi, you know, and then you need to write all kinds of you know, complicated symbols, you know. But in Julia, everything is very similar to what you write as a mathematical formula. Okay, so let me show you a quick demo of what I mean by okay. So just now when I say multiple dispatch, and here is an example. In Julia, it's actually written as a struct, and then you have a function, and then you can use this function to work on the struct. Okay, so so this is very simple example, and in terms of the multiply and the plus as the string concatenation. So here's an example, and you can see A and B are random matrix, and if you add them together, so the position doesn't matter, but when you multiply or you actually concatenate them together, I mean as a string, for example here, done hello world, so it does not equal to world times hello. But and also I also mentioned that in Julia just now you can actually overwrite, you know, with all the default packages as it is. You can actually overwrite whatever you want, you know. For example, let's say you don't like the string concatenation, and you want to add a space in between. Okay, so you can actually overwrite the base package. Base is actually the like the base of the Julia. You know, the whenever you download the Julia package, and so base is already there. So so whenever you use this string concatenation, this multiply symbol, so you are actually using the base. Okay, the base multiply symbol. Okay, but here, very simple, I can just use this one line, only one line, and nothing else. I don't have to do any compilation. I'm able to change it in such a way that the two string will be concatenated with a space in between. And then when I run hello world, it will print a space in between. That's how flexible multiple dispatch and Julia is to allow every developer, everybody, to have full control. Okay, and now when you have multiple dispatch, you have the accuracy. Now we need performance. And Julia is one of the, I would say, the first programming languages other than the traditional, let's say, Fortran or C++ that has been run on supercomputer. Okay, so here is an example. It's called the Celeste project. It's actually a project done at the Lawrence Berkeley National Lab in US. And the project actually looks at huge amounts of image data, astronomy data. And what it does is it catalogs all the visible stars in the universe. So this is very huge computationally and storage-wise, and also. And before Julia, everything was using Fortran or C++. Nothing else. And there are only a handful, let's say a few hundred, there's 200, I think, if I remember correctly, only like 200 something supercomputer in this world that allows you to achieve this kind of performance, 1.5 petaflop. Okay, because the computation is so big that a normal computer wouldn't be able to complete within reasonable amount of time. But using Julia, it's able to do it within only 15 minutes with 178 terabytes of image data with 8 billion parameters. At that time, it was ranked number 5 in the top 100 supercomputer in the world. And this kind of performance has proven that Julia can be used in supercomputer to achieve performance that has never been seen before. And the remarkable thing is that today, on your own computer, on your own laptop, you can write some Julia program that will be able to run on a supercomputer tomorrow, because that was never the case before Julia. Before Julia, what happens is that there's only a very niche, very small number of people per developer, very smart, very experienced developer in the world. They have only they have the experience, only they can program on such a big supercomputer. And the kind of code that runs on this supercomputer looks very complicated because it needs to extract all the computational power from those machines. Imagine you have 650,000 cores, CPU cores. How do you program to use all these kind of cores? And you have to take into consideration all the memory, all the communication, all these kind of issues. So the code is going to be very complicated. But with Julia, like what you have seen just now, the code looks so simple, very easy to program, very easy to run. So that's the beauty, that's the magic of Julia. And here are the benchmarks. If you compare Julia with all the other major programming languages, of course C, C++ is the standard, and you can have like Go, like Java, Python, MATLAB, Mathematica, JavaScript, all this, and Rust, and also. So the performance is very clear. You know, Julia is way better than most of the programming languages you see today. And notice that this graph is actually logarithmic scale. That means this is actually, so one bar actually represents order of magnitude, so it's 10 times. So you can see the performance of Julia. And that's the reason why, you know, people in the supercomputing world have already started to use Julia instead of you know, like Python or other languages. Okay, and because of all these features, Julia has been used in quantitative trading. And after I graduated with my PhD, I started work in quant hedge fund in London for about 3 years, and as a quant. And after that, I went back to China to start up my own fintech company, also focusing on building tools and a platform for quant trading. And essentially, quantitative trading is an interdisciplinary area between mathematics, computer science, and finance. And the workflow is as follows. First of all, you need to acquire the data, okay, market data or some other data. And you need to massage the data, you need to clean the data, you need to label it, and you can design, you can come up with some model, some strategy, and then you test it. We call it a back test. And then if the back test is good and you may want to implement it, for example, before Julia, some people may use MATLAB or Python to do the back test, but they need to have another person, or they themselves need to write, let's say, in C++ to implement it. But in Julia, you don't have to. Whatever you write for backtest, the same strategy, same code works for production, for actual trading. And then after you implement it, typically we need to do paper trading, meaning it's running in a live environment, but it's not actually using real money. It's called paper trading. And then if paper trading works well, and we will use live, we will use real money. So that's live. And after the live trading, we can reconcile. So we look at the results and what's going on, and is anything wrong, and so on. And there are very big differences between high frequency trading and medium or low frequency trading. In high frequency trading, speed is super important. In fact, latency, what we call latency, plays a huge part even at the strategy level. And if you can achieve lower frequency, much lower than your competitor, essentially you have a huge competitive advantage that could bring you tons of money every day. And but for lower or medium or lower frequency, more I think people are looking at throughput. You know, it's not though latency wasn't as important as in high frequency trading. Okay, and also they are very different. It's very different for prop trading and like big quant hedge fund. And for prop trading, it's much easier. You can use, if you look at the, let me talk about the big quant hedge fund. Typically in big quant hedge funds, there are infrastructure team which handles the development, you know, the system. And then you have the researchers which looks at the model, the strategy. And sometimes they are completely separated. But for prop trading or family offices or smaller hedge funds, they are closely, so the developer and the researchers are closely related. So sometimes some hedge fund could ask all the quants to be able to do research and development to the production all by themselves. So this varies a lot. And for all of the different types of trading, like high frequency or low frequency or small or big hedge funds, Julia can be very useful because of its accuracy, speed, and scale. And it empowers every quant to do things that they could not do in the past. Of course, quantitative trading is still considered just one domain. Julia actually has far more potential to empower everybody. In fact, I believe blockchain programming using Julia is the way to go to release all the potential of Julia. And if you look at the blockchain or distributed ledger industry today, there are so many problems, so many. For example, hard fork. What I mean by hard fork is that I'm sure you have heard of Bitcoin, Ethereum. They are very famous. They have reached a market cap they could rank in the top 2 or top 3 in terms of foreign exchange. Unfortunately, all of these so-called distributed ledger or blockchain projects have forks, meaning some group of people, they cloned their code and they made very, very, very tiny changes, and then they release it. For example, in Ethereum, there's another fork called Ethereum Classic, and in Bitcoin, there's Bitcoin Cash. So if you look at Ethereum and Ethereum Classic, the code is 99.9% same, but they are running by two different groups of people. So this kind of inconsistency, or in terms of their stability, is very damaging for the blockchain industry. And also, most of the major blockchain projects have very low TPS, transaction per second. TPS stands for transaction per second. For example, for Bitcoin, it's only about 5 to 7, and for Ethereum, it's about 20 something. But if you really want to use it in a real life, let's say like Visa, MasterCard or the Visa kind of environment or scenario, you need at least 2 or 3 or even 4 order of magnitude more in terms of TPS to be useful, to be really useful. And also there are a lot of scams, a lot of cheating and scams in the current blockchain industry or distributed ledger industry, because the person who runs the blockchain software doesn't have 100% user control. Like I said, just like Log4j, even though it looks like it's open source and it's very easy to change, but in reality, if you want to change, it's almost impossible for average user, or even for a company. Just like in the case of Log4j, even governments cannot do anything about it. Okay, even those big companies, super big multinational companies, they can't change it immediately. They have to wait 2 weeks or even 3 weeks to make the change. So that's the problem. But with Julia, things will change. And also, I believe there will be better economics possible when blockchain is being developed, blockchain project is being developed by Julia. Okay, so I expect Julia to be the programming languages for decentralized systems, and I think there's huge potential for projects that will benefit both, let's say, the quantitative trading industry and also the all the other industries. And in fact, as I said in the WhatsApp and the group, I'm going to offer courses, 4 courses in fact, to help people to realize how good Julia is and to use Julia to benefit their daily, let's say, quantitative trading, for example, or a blockchain or distributed ledger projects. The 4 courses will form the foundation for complicated projects later on. So the first 2 courses are finance and programming. So here I have 4 courses: programming, finance, and then later on I will give a course on blockchain and machine learning, AI, specifically for quant trading. So this is what I called layer 0. And I think most of the people today, if they have learned any particular area, they belong to this layer 0. So they know their own subjects. But this is not enough. In order to become competitive in the, let's say, in the job market, for example, if you want to apply a job in quantitative hedge fund, if you only know programming, or if you only know finance, or if you only know machine learning, that's not enough. That's not enough. You need to know at least one more, at least. Okay, for example, at layer 1, so 1 layer up, if you know programming and finance, you will be able to work as a quant developer. So that is actually a proper job in any quant hedge fund. Okay, and it's a well-paid and well-respected job. Okay, and if you know finance and machine learning very well, then you can become a quant researcher. Also, very good job prospect. And if you know programming and machine learning well, you can become a data scientist. Okay, there are a lot of jobs in the tech industry that requires data science. Okay, and if you know blockchain and finance, you can actually do crypto. Okay, if you know programming and the blockchain, you can do Web3. So these are the layer 1 opportunities. If you know at least two of the layer 0 skills. And going up, at layer 2, things becomes even more interesting. Let's say you are a quant developer, and then you learn machine learning. If you combine these 2 together, you will be able to do quant trading. That means in a quant hedge fund, if you can do quant developer together with machine learning very well, you will be definitely in the core team of this hedge fund. Or even as if you become more experienced, you could even become a partner of this fund. Okay? Similarly, if you are currently a quant researcher and you learn more about programming, that you can develop all these skills together, you can do quant trading. You can become a very important role inside your company. Okay, you will have very big, bargaining power. You will have big bargaining power in terms of, job. Okay. Similarly, if you know crypto, okay, if you know crypto and you know programming, you will be able to develop decentralized ecosystem, for example, like Bitcoin, okay? So that means you need at least three components at the layer 0 in order to do something very important in layer 2, okay? And ultimately, if you are able to combine the 4 components, programming, finance, machine learning, blockchain, all 4 together, you will be able to, together with 2 other things that maybe in future I will talk about, you will be able to build a complete new world. And let me give more details about the course. Okay, so first of all, I think I'm going to talk about the finance course. And the finance course is going to be more focused on fintech, because almost all the financial companies, institutions like banks, brokers, hedge funds, they are all using technology today. So hardly you will find any traditional, without any tech financial companies in the world, financial institutions in the world today. And the way how I'm going to conduct this course is actually to use a book called Market Mover by Robert Griffith. Robert is actually the ex-CEO of NASDAQ. Okay, so this book is actually his autobiography, and it was released in about 2 or 3 years ago. And I was the reviewer of the Chinese version. I was asked by the publisher of the book to write official review for this book, and it was published in their official blogs and websites. So I think this book is, I would say, a very important and even the first, I think, proper fintech book, which features most of the big events in the financial world today, up to the date of the publication, of course. And more specifically, there will be 10 sessions, 10 classes, or 10 lectures. Each lecture is about 45 minutes to 1 hour. And so I will talk about, first of all, I will talk about what is finance, what is this ecosystem? I will call it a financial ecosystem. I will give a definition of it and what are the players inside, okay? And in the second lecture, I will focus more on the people inside. In finance, unlike in manufacturing, there are a lot of material, there are machines involved. In finance, most are actually people, so they are very people intensive, very intellectual property intensive. Okay, so I will talk about the people, and one of the most important concepts in finance is leverage. Okay, and even money plays a role in leverage, and also people. Okay, so that's very important. In the third lecture, I will talk about arbitrage and API and how technology is transforming especially the quant, the hedge fund world. Okay, and then in the fourth lecture, I will talk about IPOs and quant hedge funds. And in the fifth lecture, so in actually according to this book, I have to say it. One of the causes of the 2008 Lehman crisis was actually regulatory bugs. There are problems with regulation, okay, that causes the 2008 Lehman crisis. And then in the sixth lecture, I will talk about M&A, and especially exchanges M&A, okay. And in the seventh lecture, which I consider the most important and most relevant to my own, because I'm going to talk about my experience for the Lehman crisis, Lehman in 2008, because I was actually in Lehman London office in Canary Wharf. At the summer of 2008, I was an intern there. And I finished my intern just 1 week before Lehman collapsed. So I have first-hand experience of what's going on in Lehman. In fact, I was on the fixed income trading floor. So fixed income, basically, if you look at subprime, I'm sure some of you heard of the financial crisis in 2008. It was caused by the subprime mortgages. So all the subprime actually belongs to fixed income department. So I was actually at the right at the center of the 2008 financial crisis. And in the 8th lecture, I will talk about globalization, because finance is global. Everything is global today. And inevitably, politics is involved. So we need to understand what are the factors. And then in the 9th lecture, I will talk about high-frequency trading, because in quant hedge funds, high-frequency trading is super important. In fact, today, Robert Griffith, so after he left NASDAQ, he actually joined Virtu, which is a high-frequency quantitative hedge fund in US, and it went public as well. So it's doing great, and they earned a lot of money. In fact, I think before they went public, for about two years, every day, almost every day, that hedge fund, Virtu, made money. I think only one day they made a loss. So that's how powerful high-frequency trading is. And I will talk about the exchange system bugs, which was one of the reasons why Robert has to leave NASDAQ. Okay, and lastly, in the last lecture, I will talk about flash crash, and how the media play a part in the system. Okay, so this is the outline for finance costs. And then for the programming costs, which of course will be about Julia. Also 10 courses, 10 lectures. I will talk about the data abstraction, how data is being processed, and the data structure, how to represent, how to structure data, and how you store it, like database, okay, or data store. And also how you visualize. So once you have, let's say you have a backtest, you want to visualize it. So how do you do it? Also, one of the main packages in Julia for data analysis is called the data frame. Okay, and I'm going to focus on data frame in the 6th lecture. And in the 7th lecture, I'm going to give more details about multiple dispatch and how the function, various ways you can write functions. And in the 8th lecture, I'm going to talk about algorithms, which is super important if you want to develop any general purpose software or systems. Okay, and in the 9th, I will talk about complexity and performance, because like I said, especially in high frequency trading, so performance, the latency is almost everything. It's almost everything. And if you are able to write super fast program, you will find jobs in the quant hedge fund industry very easily. And lastly, I will talk about parallel and distributed computing, because, for example, when you do large-scale simulations or backtests, for example, you need a lot of CPUs or GPUs, for example, and it could be distributed. So it doesn't have to be on one machine. It can be multiple machines, multiple cores. So how do you do it? So if you need the latency, if you need the throughput, so all of these are needed, okay? So, so after the 2 courses, I'm going to offer 2 more courses, which is on blockchain-based decentralized systems, which is blockchain-based. And then I'm going to give AI or machine learning course as well. It's more focused on quant trading, okay? And at the same time, I'm going to lead 3 projects, okay? 3 projects. And the first one is called the Decentralized Julia-based development platform. What I mean by that is that, so today, if you want to write any program, typically you write it, let's say, in Python, in JavaScript, in Java, or C++. But how to do it in Julia? And also to write it in a true decentralized fashion. So there are a lot of missing packages there for Julia to be fully utilized by the industry. Okay, so as the first project, I'm going to focus on building this development platform. And then using this decentralized Julia development platform, I'm going to build an extension of the Bitcoin protocol. Okay, so this is going to be very important for the distributed ledger, the blockchain industry. And I think I'm going to do something very different from what you have seen in the past. And after that, I'm going to do another project, the third one, which is called the Quant Trading on decentralized systems. So what I mean by that is that, in fact, if you look at this diagram, okay, today, if you know programming, if you know finance and machine learning, AI, so these 3 components, it's good enough for you to do quant trading. But this kind of quant trading is limited to the existing financial infrastructure or the environment. So there are limitations. And that's the reason why a lot of the DeFi, decentralized finance industry, a lot of people are very interested in the DeFi projects. So that's why even if you know quant trading, it's better to have this blockchain component combined, okay, so that you are able to do much more than purely quant trading. You know, you will have much more control, you will have more freedom. So that's why I call it quant trading on decentralized systems. Okay, so so here are all the courses and the projects. And the courses currently I'm offering, it will start very soon, and once I have enough people to join, I can start immediately. In fact, I offered the 2 courses in Chinese about 1.5 years ago. Yes, in Chinese. And now I'm going to make it even better and in English. So the 2 courses, finance and the programming. And if you take the 2 altogether, there will be a discount. So altogether will be 5,000 dirham. So if you take each one of them, it will be 3,000 dirham. So that's how it will work. And it will be held online, and I will give all the slides and some codes as well. Okay, so that's all for today's talk. I hope you like it, and if you have any questions, so you can write it in the chat box. Okay, I saw someone ask a question. Okay, Paul asked a question: was the log4 shell issue not a hack through any search field like item by faking to an execution? Okay, so the question is about the log4j bug that I mentioned. So the issue wasn't a hack, you know. It's you can't hack into. I mean, if it's a simple hack, then it won't be as severe as it is. Okay, so it's much more complicated than a simple hack. And you can read the description in the Wikipedia page that I showed just now. So you will get more information. So Julia to replace Solidity. Solidity is basically for Ethereum. So Julia is more general purpose. Okay. Solidity only works on very small set of machines, basically virtual machines, Ethereum virtual machines. But if you want to do it without EVM, if you want to do it just purely on a native computer, you can't use Solidity. You have to use something like C++ or Julia or Python. So I wouldn't compare Julia with Solidity. No, it's completely different. Okay, any other questions? Okay, so if there's no more questions, so I will end the live stream. So if you have any questions, you can ask me offline on LinkedIn or on WhatsApp. Okay, yeah, thank you very much, and hope to see you in the lecture. Thank you, bye-bye.